the summer of 2013, it was impossible to ignore. The water had not arrived, and Idaho was on fire. To some, this was hardly a surprise. It had been building for a while.
I'm looking for charcoal in this.
Jennifer Pierce studies climate and the history of fire. She gathers evidence at the source of historical fires in Idaho, going back almost 10,000 years.
Come back and collect some of this.
So I look for evidence of these past fires by digging up small pieces of charcoal buried in sediments, and I date that charcoal, and that gives me a longer history of fire.
Pierce says fire was rare from the 1400s up to the 1900s. A big fire happened about every 200 to 400 years. But by the 1980s, something had changed. Massive wildfires like the 1988 Yellowstone fire had become more common.
Starting again in about 1985, there was an increase in the size and severity of fires throughout the western U.S. And the cause of those large fires is overwhelmingly climate. When you look at the data, those large fires are burning again throughout a range of ecosystems, regardless of prior management.
The close relationship between climate, fire, and water is no surprise.
Climate really defines us as Idahoans, and climate provides a template for a lot of the resources, our water resources, our land resources, forestry, agriculture, energy, tourism, recreation. All those really come back to water in the end.
Climate dictates how much water falls from the sky and what happens to the water on the ground. Hotter temperatures, a changing water cycle, more fire. But while climate change is a concern to most scientists, Professor of Forestry Jay O'Loughlin has focused his attention on the things we might do to reduce the impact of more frequent fires.
So we've altered the fire regime in many of our forests by not allowing fires to burn. And that does have some consequences that come with it, which means the next fire is going to be bigger because you've accumulated more fuel. That fuel management is really the key here. That by allowing our managers to do active fuel management, to create conditions that will make our forests and our watersheds more resilient.
More than 60% of Idaho is federally owned and managed. The procedure to harvest timber in national forests is plagued by red tape and a multi-year process, says O'Loughlin, and that results in fires that have plenty of fuel to burn.
One of those impacts that we care deeply about is water quality, and water quality is affected by sediment.
One example is the Big Wood River, a week after the Beaver Creek fire in central Idaho. And frequent fire means certain plant species won't have time to rebound, laying the groundwork for other plant species. Take cheatgrass, for example, a fast-growing plant that offers fuel to new fires. In the science world, it's called type conversion.
That has certainly already starting to take place, where forests that have burned, for example, in the Southwest, are not being replaced by trees, they're being replaced by shrubs. I think, a real concern of mine is that if there is a fire in the Boise front, will the trees up at Bogus grow back? These are trees that germinated during the Little Ice Age, a time characterized by cooler climates than today. And our current climate may not be suitable for trees.
University of Idaho professor Jana Batsaglu says this is just one way climate will change the state in some dramatic ways. His research models predict a potential 7 to 10 degree temperature increase in populated areas of Idaho by the end of the 21st century.
Summer temperatures in McCall be a lot like current summer temperatures are today in Boise. And for Boise, if we consider what summer temperatures might look like in Boise by the end of the 21st century, And we think about where we'd have to go today to find temperatures like that. We would have to go quite some distance, thousands of miles away, outside of the Pacific Northwest.
Imagine pushing Idaho down 2,000 feet. Places like Idaho City, Ketchum, and Salmon would all have climates similar to Twin Falls and Boise today.
One thing that we do see from these modeled projections are an increase in precipitation during our cooler months and a decrease during our warmer months. So that's basically like the rich getting richer and the poor getting poorer in terms of amplifying the seasonality of precipitation.